Today's video is going to be on complex numbers. So just hang on, this is going to be an introduction video, and then after it we're going to work on some problems together and see if you were listening. Complex numbers. So like in your math journey, you have come across where you wanted to maybe it's something like -92 and this was under a root and you put it in your calculator and it gives you something with an I and you don't know what it is. So let's go back to the mapping of numbers. So we have a line of real numbers here and we have imaginary numbers. So some numbers have both parts. They made of two parts and we call those numbers complex numbers. They're made of a real part and an imaginary part. Let me say bi. So those numbers are just here. They they're like that. They're made of real and um, imaginary parts. So from this you can see this one is a real part and this one is imaginary part. It's your imaginary part. So let's get back to where we started. So for a case, let me say you have a case of root -1. That was supposed to be -1. So root -1 is equals to I. Okay? And we can square both sides. Let me just use a different color so that you don't confuse it. We can square both sides and your I squared is going to equal to -1. Okay? From then the pattern can keep on. Your I cube is going to equal to I cube is literally your I squared multiplied by your I. You already know your I squared now. You know your I squared is equal to -1 multiplied by I. Then I cube is going to equal to negative I. Okay, let's look at I power 4. I power 4 is same as I squared multiplied by I squared. And these you can do lots of exponent, take one place and add the exponent. It's going to land just here. We know I squared, we just work with I squared is -1 and you can have -1 again here, and then -1 and -1 are going to give you what? A +1. Now we know that -1 is equals to I squared. That's what we just learned now. We also know that root -1 is going to equal to your I, and we have also know that I squared is going to equal to your -I, and we also know that your I power 4 is going to equal to your +1. You could notice that this thing keep on revolving around this plane. The first one was positive and imaginary with a 0 real part, and the next one was real but negative. The next one was negative and unreal. The next one was the cycle keep on going as they move further away from the radius. But you understand this the time we're doing all the plotting of real numbers. I mean unreal numbers, complex numbers. Okay. Okay, let me say you're given something like I12. You don't know how to do it because on this scope that I give you, there is no I12. But I12 can be represented as I power 4 and 3. It's going to be 12 is equal to 4 times 3, right? So with this, I haven't broken any math rules and haven't done anything clever, right? So you know your I power 4 to be what? You know it's just here, it's equals to 1. And then you have your power 3 there, and then you have your 1. One of the most important thing that I need you to take into account is this one. Put this in notebook is very important because if you give them very huge powers here, it's very easy just to get the factor of 4 and put it there, and then the remaining will be just 1, then the remaining will just work out. It will be easy. For instance, let me say you're given a case of let me say, let me just remove this. Let me say in your test you made something like I to the power 200. You can't obviously go with this person until you reach 200. What you do, you always use this one, the 4, the I power 4. The I power 4 is the most powerful because if any number, you can just get where 4, how many times can 4 get in this number? From 200, you can have 4 power 50, right? You can have 4 power 50, 50, 100, 150, yes. And then you have your I power 4 and your 50 outside. And this one, you know it's going to be 1, obviously. Power 50 is going to be 1 again. So this is your answer. Let me say it was a different case. For instance, you're given something like I 402. I 402. So it's going to be the same thing again. You know what you do? How many times 4 can come here? In 200 we have 4. Obviously we're going to have 8, right? We are going to have, sorry, oh, we are going to have 100 here. So we're going to have I and 100. So it's going to be 4. Outside is going to be 100. But we still have a 2 here. To make it a 2, remember, same base at the exponent, we're going to have an I with a 2 here. So we just resolve it very easy. It's any number, no matter how big is the number complex, just get it where how many times can 4 can get in. Then what is remaining, you put it on the other I. Okay, as the here part was remaining was this 2, and then we made a 2 just to compensate for it. Okay, then from this one is obviously going to be 1, and then I squared, we do have y I squared from our scope is going to be negative 1. And then the correct answer is going to be negative 1. Okay, this can go on to other big numbers, like maybe you have, I don't know, maybe you have I is equal I power 72, and then you require to get its value. Okay, I was just making a number up hoping that it would be not be a factor of 4, and it just happened to be 4 again. So 4 goes here like 18 times. You can have your 4 here and your 18 times. Then this is going to give back your 72. So 4 is obviously going to be 1 power 18, doesn't change anything, go back to 1. So yeah, you can make use of this to solve most of your problems. Remember, if there's anything remaining, you compensate with this part here. Then let's move to addition of complex numbers. Before we move forward, let's try one more last one. It's going to be I power 19, and I hope it's become one that I wanted. It's going to be I, and then we can have 16 next to this one. Then it's going to be 4, and the 4 outside multiplied by, this is 16, we wanted 19, so we still miss something. We miss 3, because we can add this, that can give us back to that one. And again, this one is going to be 1. I power 3 is going to be negative I, and then that is going to give you a negative I. So in these questions where there is I raised to some power n or whatever that I don't know, the answer is going to revolve around these values. It can't be anything outside these. So make sure that if you're in a test, you get answer is none of these, then that should be you. You should have made a mistake there, but we hope that you don't do that mistake, right? Now we're adding complex numbers. When you're adding complex numbers, it's simply as you add the real part to the real part, and you add the imaginary part to the imaginary part. What do I mean about that? Remember I said the complex numbers are made of two parts, the real and the complex numbers, and I still have that note here. Okay, so it's going to be a plus bi, the real and unreal part. I'm adding to another that is c plus di. The sum is going to be the real goes to the real, so I will have a plus c, that is real part, plus the imaginary part is going to be b plus d, that is going to be b plus d I. This is all you need to know to add your complex numbers. Let's do some couple of two examples maybe, then move to the next topic. Let me say you presented on a test with a problem like this one. You're supposed to add these two complex numbers. This could be the one, this could be the other one. Maybe they've called it A and they call it B, then they said add A plus B. But this is what you need to do. Remember what we did the previous example? Real part to the real part. Real is 2 plus 3, and then it's going to give you something like 5. And then 12 plus minus 4 is going to give you, obviously, this minus this is going to give you 2. I'm saying 2 minus and then you can 8. Okay, 8. Okay, this is going to be your answer. Remember, the real part to the real part and the imaginary part to the imaginary part. And then you can get your sum or your difference. This goes the same if you have to do difference between two complex numbers. This is a very same principle. Let me say you presented the problem like this. You're given two complex numbers, A and B, and they say find a difference between these two numbers, A minus B. Let me keep them kept as they are there. A minus B. They say find a difference between these two complex numbers. This is what you need to do. Simply, it's A first, it's 10 minus 2i and minus B. Minus B. I put minus and then let me just distribute this minus all over here. It's going to be plus 2. This is going to be minus 9i. Then you keep on with your principle. The real part to the real part is going to give you 12 real parts, and this to this is going to be minus 11 imaginary parts, and this is your answer now. Your difference between these two are complex numbers. You could even be asked to do a plus b. Sum of these two complex numbers is going to be 10 minus 2i minus 2 minus 9i. Then the real part to the real part, you get 8. The imaginary part to the imaginary part, you get minus 11i. Here obviously I did a mistake. The time that I changed all the sign, I changed 2, I didn't change this one. So if this one become positive, this is going to be 7 here, not this. Is going to be 7 here. If I do a mistake, don't mind to comment and tell me if I did a mistake somewhere in the mathematics. But I hope that I don't do critical mistake. Obviously I won't. Let me say you're given two complex numbers here. The one that I have just made up here, these two complex numbers. They said find the quotient, or you should divide the other one with the other. It's going to be 5 minus 2i all over 3 minus 6i. So the question is, how do you handle this? So to get rid of the unreal part in the bottom, you're always going to have to multiply with the conjugate. The conjugate is just 3. Here it's plus, it's minus, going to be plus. Here 6i. Just that you are just that, because you want to keep the value of this expression the same, you have to do what we did bottom to do then the numerator also. So it's going to be 3 plus 6i. You know that multiplying by something of same denominator and numerator really doesn't matter, because it's just going to be 1. So multiplying by 1 doesn't change the value, right? Okay, so then I don't know if we did multiplication. We're supposed to do multiplication before we do division, but yeah, you go. So this goes to this, right? You do your FOIL, and this goes to that, this goes to that, you do your FOIL. So you take this to this, you're obviously going to get 9. You take the same 3 to this, you're going to get what? You're going to get 6, 12, 18, and then you're going to get plus 18 plus 18i. Then you go to the second term now. This times this is going to give you minus, this is supposed to be 18 minus 18i, and this by that one is going to give you negative 6 times 6 is going to be 36, and then I is going to give you I squared. This is on the denominator, right? I was supposed to leave a space for it. This was the denominator I was working in, so it should be all over the numerator. The numerator, you do the same thing. If you notice here, these ones are going to cancel each other. I should have not done it. I was just doing it because of the first problem. But if you're multiplying by a conjugate, always just going to multiply the first and the last, and you'll multiply the last and the first. That's all. So then on the numerator, because there's not a conjugate of this, you do it the right way. This by this is going to give you 15, and this by that one, this was 6. 6, it's going to give you what? 5 by 5 would have been 25, and it's going to be 30 plus 30 I, and then we move to this one. This by this is going to give you minus 6I, and that by that one is going to give you minus 12I squared. So from here you can do the math. First math that you need to do, you need to just eliminate this one. I should have not even bring them here. Eliminate all these ones because they cancel each other. And the other thing that you should notice is that I squared, we said I squared is equal to -1. So you can just take it out because it's just this -1 can just change this to plus. Okay, and then we work on the like terms, and then we have 12 and this was 15, which is going to give us 27 obviously. So we have 27, and the imaginary part we have 30 minus 6, giving us plus 24. All over on the bottom, what do we have? And again, remember this I squared just change this to plus, and it's go away, and you're going to have 36 plus this one, and then the 3 goes here, making it make or the 4 goes here, making it 40, and then remaining with uh 5 here. Then it's going to be 45. And again here we had this difference here. I was supposed to put an I here. Then from here you could just make it to you're done. You can make it to your basic format, of which is going to be 27 over 4 5 uh, plus 24I all over 4 5. Remember, we have I here. We have now have a real part and imaginary part. If I say find the product of these two complex numbers, it's the same as what we just done before. Now we're finding the product. So it's just going to be 5 minus 2I close open 3 plus 6I close. Then we do the full thing. This by this one is going to give us 15, and this by the other one is going to give us 30, and this by this one is going to give us minus 6I, and that by that one is going to give us um, minus 12I squared. Then if I did my math very well, I can now find the factors, the uh, commons with the same, with all those with the i's. I can just add them together. It's going to give us 24I, and this is going to give us this I squared is going to change. Remember, the I squared changed to -1, changes to plus, and then we're going to have what? This plus that one is going to give us 27, the real part, and this one was positive. This is going to be our answer. The most important thing, let me say you're dividing or you're trying to find the quotient of complex numbers, it's going to be a plus bi all over c plus di. The most important step is multiplying by the conjugate. So you're going to see if this one is plus, it's going to be minus di c minus di, because this one is the same. You're just going to change, not going to change the value of the whole expression, so you're just more than welcome to do it, and from here you can work out everything. So one last problem before Let's look at another problem before we finish. So this is going to be 5 minus 2i all over I. So you could just do the same thing as I did, the minus the conjugate. So the conjugate here, you could just multiply by a conjugate, of which is what I just taught you. You could apply it, or you could just forget about everything I taught you, just do your math. Okay, let's focus on the math first. Let's do the basic math that you would have done if you didn't know about complex numbers. You'd have just say 5 divided by I, and here we have 2 minus I, blah blah blah, of which you don't want to do that. You want to multiply by an I squared. You multiply by I both sides. So it's going to be multiplied by I all over multiplied by I. And this is going to give you an I squared. You know what is I squared? I have it just here for you. It's going to be negative 1. So you have negative 1 here. And this one is going to change to be 5I, because I just displaced this 5I inside. And this one is going to be minus 2, that was supposed to be a 2i, and this by this is going to give you what? I squared. What do you know about I squared? They equals to 1, and what they do, they just change this one and disappear. Okay, so our I squared is gone. We're going to have what? 5i plus 2 all over negative 1, and you could just simplify this to make it minus 2 minus 5 I haven't done anything clever. I just multiply all by negative, and I've shoved it to the most friendly format. Now you are about to finish the video, so you're equipped with all the operations that you need to be able to do to work with complex numbers. One more thing, you need to be able to solve complex numbers equations, I mean. So you're going to have like 3x plus 4i is equals to 15 plus 6yi. So remember, I've been telling you that you always associate the reals only and the unreals only, or the imaginary only. So here, for this equation to be equal, it needs to satisfy this condition. The real parts need to be equal to the real parts of the other equation, and also the imaginary parts need to equal to the imaginary parts of the other equation. So what do I mean by that? I mean to say 3x 3x should equals to 15, and 4i needs to equals to 6yi. Okay, take note that I use an AND connector here. You learn that on the logics, of which you need to know when you use OR and where you use AND. But for the purpose of the video, I won't touch it. But AND, these cases, both of them need to be true for the statement to be true. For OR, either of these cases need to be true, then the statement could be true. So OR is very straight. I mean, AND is very straight because it needs both of them to be true, while OR needs just one of them to be true. Okay, so we need x2, and then we're going to solve for x here is going to be 15 over 3. I think that should be equals to 5. And the y here should, what is happening here? We want to solve for I, right? Okay, so we're solving for y, I mean. So we're just going to divide by 6 over I by 6 over I. Then the i's are going to disappear, and you have 2 over 3 is equals to y. So this value of x and this value of y satisfy this expression. Take note, and connector here. So both of these need to be true to take this equation is true, or maybe should I say the truth value of this equation to be true. But for more in logics and connectors, I have a video that I'm just going to attach a link just here, and you just go watch there. Thank you. Please subscribe, like the video if you find it informative, and don't forget to share it.